TopMedTalk.
Hello, I'm Desiree Chappell, and this is TopMedTalk. As the coronavirus pandemic continues, we continue our conversations with care providers around the world to shed light on the crisis. Our series, COVID from the Front Lines, highlights healthcare workers on the ground and those in more supportive roles, and we want to share those stories in hopes to provide education and support for all of our listeners. I'm in Louisville, Kentucky, and we're joined by our editor-in-chief, Monty Mythen, in London.
Hey, Desiree. How are you today?
I'm doing okay. How are you doing?
I'm feeling pretty good today, but a little bit brighter. I was into the hospital this morning, to the hospital where we restarted our scheduled cancer surgery, to around there with my colleagues and see the patients. And they've adorned the whole front of the building with coloured balloons, which are a rainbow, which they've done to a number of different hospitals in different places, basically to say thank you to NHS workers.
That's so sweet. I've seen that quite a bit.
I'll share an image of it later on.
Yeah.
And on one of the balloons, it says, "We are the NHS," if you see what I mean, with a rainbow logo. But when I first read it, I read it as "Weary NHS." If you tired of it, I thought, okay, it's nice to share that. It's nice to share that. But we do get the impression that people have been working incredibly hard. We do get the impression that things are slowing down a little bit in London, and right at the moment they're coping very well, because people do need some respite. They do need some rest, the nurses in particular.
Yeah, absolutely. It's been a major strain on all workers involved. Well, Monty, joining us is a TopMedTalk fave and partner, Professor Mike Grocott from Southampton there in England. Hello, Mike.
Good morning, Desiree. How are you? I
am doing great. Tell us how things are down there in Southampton.
I guess we're in a similar position. The impression is that we are passing or have passed the peak. The number of patients coming in is going down, and the number of patients on the units going down. And we're actually, whereas we'd thought our next step would be to expand again, I think our next step may be to contract a little bit in terms of critical care footprint. So we're good.
Oh, that's good. And are you guys starting up elective surgery, or just still sticking with kind of the more major scheduled stuff?
No, we're starting up elective surgery. We've partnered up with our local private hospital, where essentially the NHS has taken that over for the moment contractually. And we're also just looking at kicking off elective surgery on the main side. So we're slowly starting to get the wheels turning, but also very conscious that whilst the peak may have been avoided, we flattened the curve, as everybody said, we're just very suspicious that the area under the curve may remain very, very substantial, and we're really going to be at this for months and months and months.
Mike, you've been on the television a lot, as just seen you on Sky News representing our community, but also in your role as Vice President of the Royal College of Anaesthetists. And every time I see you on the telly, it's usually in your study, and I can't help but notice over your shoulder, I know exactly what that picture is, which probably no one else does, but I'm going to give it away now. That's a picture of you and your colleagues having summited Mount Everest and the blood gases that you drew afterwards. Now, hypoxemia and the human tolerance of hypoxemia is extremely commonly discussed at the moment. How low should you let people go? How low, and we can't make direct comparisons here, but we'll come back to some of the biology of this in a second. How low did you guys go?
So we had arterial PO2s of less than 30 kilopascals, so in a range of from 19 to 27 kilopascals, so in millimeters of mercury. That's down at
23 or something. Yeah, so extreme, way below. So if we do it in kilopascals, we'd be panicking about patients at the moment about 8. You were way
past an ECMO referral.
Yeah, so we can't make direct comparisons because you'd been through the acclimatization process and young, fit, and possibly genetically adapted in different ways. And that's the story I want us to pursue. We're overdue doing it. We keep discussing it. And that is the ACE polymorphism story. So before we bring in our next expert guest, Desiree, Mike, a thumbnail sketch from you as to what you thought that story was when we first went to Everest.
So we have this the ACE gene, and I'm given our next guest, I'm feeling somewhat self-conscious here, but I'll have to go. So you've got the I and D alleles, And the eye, from a long series of pieces of work around left ventricular hypertrophy and then athletic training, it became clear that the eye allele was associated with, i.e. overrepresented in people who were endurance athletes. And then there was some work done at altitude, whereby very experienced high-altitude mountaineers who hadn't had altitude illness were genotyped. And again, there was an overrepresentation of the eye allele. So a suggestion that it was beneficial in individuals at altitude. And concurrently with that work, there was work at your hospital, at UCLH, looking at very severe lung injury, so ARDS, which suggested a survival benefit, quite a substantial survival benefit with the same allele that is beneficial at altitude, so this eye allele of the ACE gene.
So before Desiree brings our next guest in, do you know, I don't know what my ACE genotype, I've always avoided finding out by some method. What I've got a strong suspicion what it might be. Do you know what yours is?
I don't. Okay. Our next guest may, but I definitely do.
Desiree, over to you.
Okay, well, let's break the suspense because I know it's killing everyone to hear. So our next guest is TopMedTalk favorite, another new TV personality as well, I believe, there in the UK and international. I've even shared some of your pieces. But it's Professor Hugh Montgomery from London, England, there at UCL. Hi, Hugh. How are you?
Not so bad, thank you. Yes, touching wood somewhere, can't find any. I don't think I've been struck down with the virus yet, but of course it's possible I was and didn't notice. But having heard Monty's experience of it and others, I don't relish the thought, actually.
Yeah, no doubt we're all very lucky who haven't had major experiences with that. Hugh, two questions. One, do you know Monty's, what he is? And then two, did Mike totally butcher that or did he get it right?
I don't know what Monty's genotype is. Most people, oddly enough, are quite good at telling. So we have done the study with students where we tell them about particular athletic performance and we ask them to predict their own genotype. And the II genotype, which is the low ACE activity group, and the DD genotype, who are the high ACE activity group, are pretty good at predicting what they are. In that IIs are the ones who start the sort of cross-country season and pick up the long-distance running really, really easily. And the DDs are the one who tend to stack on the muscle very quickly at the beginning of a training session. And most people who've done any athletics or physical activity know if they fall into one of those two groups. And there's some big giveaways. If you're a good swimmer, competitive swimmer, that's a really strong signal for being DD as well. So a lot of people are good at predicting. So I would reckon Monty may well be right.
Yeah, because I used to do field sports and throw things predominantly in the athletics and played rugby, for example. None of them extremely well, but I could bulk up if I went to the gym and worked really hard at it. Whereas some people you'd see, by the end of week one, they looked as though they were on steroids of some form, and other people, it was just a waste of time going to the gym. It just never happened. Yeah, absolutely right. And so I suppose you probably want to talk about how that links into this story, although Mike's given a pretty good summary of it. Well done, Mike. You've been paying attention over the years. So the story is exactly as Mike described. These alleles, obviously all genes come in pairs, and the ACE gene makes or encodes angiotensin converting enzyme, and we all have two ACE genes. And in most Western populations, those alleles have a variant in them. Insertion variant, or I, has a little extra bit of DNA in the deletion, or D bit has a bit missing, and they're equally prevalent. So roughly a quarter of people will be II, low ACE activity. Roughly half will be, as Monty's predicting himself, to be an I and a D, middle ACE activity, and the DD group have high ACE activity. And we were able to show that the DD genotype, by making angiotensin converting enzyme, synthesizes angiotensin 2, which is a very powerful vasoconstrictor, but it's also important for muscle growth. So the DD groups are very good at grading muscle. But angiotensin 2 also mucks around with metabolism in mitochondria and makes it less efficient. And we were able to show that the low ACE activity group had much better efficiency into the way they used oxygen. And we could show that in cells as well. And that partly relates to direct effects on mitochondria. So basically, you can get more energy for less oxygen if you're an II.
Now, we then took that indeed to the ARDS patients, and people like Monty and Mike and I are old enough to remember ARDS in the 90s. It was highly prevalent. Our wards were full, weren't they, Monty, of patients exactly like this in terms of lungs. Stiff, solid lungs, very low oxygen, very hard to ventilate outside very high pressures. And I was working at the time with Rich Marshall, and we did the study of genotyping very clearly defined ARDS patients. And there was a 500% difference in mortality. So the low ACE activity group had a mortality of a little less than 10%, and the high ACE activity group had a mortality of above 50%. And there are very few things in medical practice that we could influence outcomes to that degree. So these were all getting what we would consider optimal care as best Monty and I and Mike could deliver in those days. And yet the genetics was so strongly determining the outcome.
And Hugh, was that replicated, which is often a question?
Yes, it was. It was replicated in other groups in China and elsewhere. The groups that failed to find replicative data, essentially it came down to the tightness of the phenotyping. If you just dump people with a bit of respiratory problem in a bucket and call it ARDS, you're likely to dilute the signal. So the studies where they were very tightly phenotyped found exactly what we'd found too. But Rich had gone to a lot of effort to not just go, oh, we think the ventricle's probably all right, but to make sure the ventricle was all right, the PA pressures were not elevated, and so forth. So I guess the big question for us now is where with ACE. So ACE, as we've said, makes angiotensin 2. And angiotensin 2, there's part of the degrading process of that involves an enzyme called ACE2. Which creates another peptide called angiotensin. Now, ACE2 turns out to be the enzyme expressed in a variety of cells in the human body that's hijacked by the coronavirus to get into the cell. So a little bit of the biology. I'm sure you're all over it, Monty and Mike and others. But the coronavirus is so cool because it has this corona or crown of spike proteins that stick out. And these are glycoprotein spikes. And they form themselves into trimers, or little groups of 3 spikes, 1 pointing up and 2 pointing down. And that little grouping of a triple spike is what sticks into the cell receptor to get in. Now, if ACE2, the enzyme expressed on the cell surface, dimerizes, so groups together to form a pair, then the coronavirus trimers can stick in. So 2 can stick into these 2 ACE2 molecules next to each other. Now, your body then goes, hang on, I don't like this. I'm going to chop off the end of that spike protein, the S1 protein, and it uses a protease to do that. But unfortunately, that defense mechanism of chopping off the end of the spike actually is what the virus uses. It exposes the second part of the spike protein, the S2 protein, which allows the virus to weld its capsule to the cell wall, and then it can dump its viral contents inside the cell and hijack the protein synthesizing mechanisms inside the cell and typical viral stuff. It just manufactures a tank load more of itself, the cell dies, the virus spills out, and we're off to the races. And it turns out this virus is quite sneaky in that it can switch on production of ACE2. So it can make cells make more of the receptor as a little trapdoor to get into the cells. And we're seeing that, for instance, in kidneys. So the story goes, would you or would you not want an ACE inhibitor or an ARB? And indeed, are these drugs the reason why hypertensive patients are more represented on intensive care units? The drug is making them sick. Yeah.
And Hugh, because we have a very broad audience listening to all of this, the ACE and the ARBs are drugs that are commonly used out there in medicine at the moment to treat blood pressure, for example.
Absolutely. The ACE inhibitors, because they block ACE and mean that you make less of this agent, angiotensin 2, that tightens up blood vessels, are very good at lowering blood pressure. They're very good for treating heart failure. They're also widely used in diabetes because they help protect kidneys from the effects of diabetes. So these drugs are out there. The ARBs are angiotensin 2 type 1 receptor blockers, so they block the angiotensin 2 working downstream. Well, the answer to the first bit of the story is there are no data to support the fact the drug is the dangerous thing. It doesn't seem as if people on the drug are more likely to end up getting coronavirus, because if you block ACE, you could increase ACE2 activity, which could be a bad thing. but there's no evidence that that's the case. So the next question is, well, if you then ended up on an intensive care unit horribile, would you want an ACE inhibitor? And again, you could argue it both ways. You could say, well, by increasing ACE2 availability in the cell, more virus gets in. That's bad. Or you could say by increasing ACE2 in the circulation that mops up the virus, that's good. Or you might say, once the virus is largely gone, you're dealing with ARDS, in which case we're back to where we were in the 1990s to say, in theory, lowering ACE activity could massively increase your chance of survival. So do we have any data?
Of the various different trials that are ongoing at the moment, because we have trials that have been activated that have multiple different limbs.
Yes.
Is there a trial somewhere where one of the limbs is ACE inhibitors?
No, there isn't that I'm aware of, certainly not in the United Kingdom. And that's partly because there's a competitive market would be the wrong thing to say. There's had to be a prioritization of trials, quite rightly, to make sure there isn't massive dilution across a range of fronts. So I think certainly in the United Kingdom, because we have a National Health Service and a National Institute for Health Research, and because we tend to be collegiate and know each other, we've all played by the rules. And when we've been told the big trials to go for these ones, we've all gone after those trials. And they're recruiting really, really well as a result. Once those trials have some data on which of those drugs work, then I would like to see the ACE inhibition trial being done. The data, the signals we've got at the moment are weak and they're all associative. The first thing is we don't yet have the genetic data because that would answer the question. If you have a clear association of low ACE activity genotype with improved outcome, it really would provide very strong evidence of benefit.
If I may, Hugh, I have seen some data published, not to directly answer that question, but by countries, because we've got an even spread, haven't we? There are countries that have an uneven spread of II and DD.
Correct.
And the story does seem to play out. Is that right?
It does. So one has to exclude some country data because the influence of this particular genetic variant on ACE activity, for instance, isn't there if you look at people from West African origin or Southern Black African origin, where the ACE the type of that nature, the ID, is not really very informative. But elsewhere, you're right. The places with the most severe and high impact disease have tended to be those with the high D allele frequency. That's the high ACE activity groups. The second thing is there's been one paper out so far showing an association with what appears to be a threefold reduction in mortality in patients who are taking ACE inhibitors or ARBs. And we've got to be very careful here that we don't ascribe causation to association because that may exist for a bunch of different reasons. But as part of the narrative, it would tend to fit. Now, I'm a scientist, clinician, and I'm a collegiate player. So the answer is, as we're doing in Britain, no drugs to be given outside a proper clinical trial because that's the only way we get the answer. But on a personal basis, if I had to say, were it me and I were in a trial, would I want to be in the group that got the ACE inhibitor? I think once I hit the ITU and I'm through that first hit, the answer is yes. Because I think a lot of the time the virus is gone. And what we're dealing with is this massive pro-inflammatory process driving an ARDS process. And I would probably say an ACE inhibitor may be to my advantage, but I don't know. And I'd be happy to be entered into a randomized trial to find out.
So I think what I'm taking from that, Hugh, is that you're not recommending that because you can't recommend that because we don't have the evidence to recommend that. But if you were given a personal choice, you would take one. And if you were given a chance to enter a trial, you'd enter the trial accepting the fact that you might get the limb that doesn't get one.
That's absolutely right. And it's worth pointing out that whilst we've been focused very much on the oxygen side, the hypoxia side, that this will help you survive low oxygen, we know that high ACE activity does a couple of other things. It's very, very pro-inflammatory. So angiotensin 2 is a very pro-inflammatory driver, and that applies to eyes and brains and hearts and blood vessels and kidneys and so forth. The second thing is, those that are older than us to remember ARDS, is we know that you get this fibroproliferation, essentially a scarring process in the lung, where the lungs become very stiff. They lay down type 3 collagen, which has a tensile strength greater than that of steel, and it makes the lungs very, very hard to ventilate. And angiotensin 2 is the major driver of lung fibrosis. It's the molecule downstream of many others that drives scarring in lung tissue. So an ACE inhibitor may have a triple benefit: damping down inflammation, improving your handling of oxygen, and preventing the fibrosis and scarring in lungs that are there as well. And it's for those reasons why, if I had to put my money on it, I would put my money on taking an ACE inhibitor.
To me, the barn door obvious question is, do we have any ACE2 antagonists? And if we did, would they help?
It's a really good question. And there are drugs out there that interfere with ACE2. In fact, though, one of the drugs counterintuitively that looks as if it might work and is already in trials is a recombinant human ACE2, on the basis that if you give that at the time of the infection systemically, so into blood, that ACE2 will mop up the virus. So it will compete with the cellular receptors and will take the virus out of the circulation. And I don't know what the early data are, but I do know that molecule has been used in man before. It's been shown to be safe without significant adverse effects at all. And it's been shown to have some potential benefits to the treatment of other lung diseases that involve lung scarring and fibrosis. So an ACE2 molecule, by breaking down angiotensin 2, which is pro-inflammatory, may in fact have some very distinct advantages for all of those reasons. And that works strangely in harmony with ACE inhibitors themselves.
As you will know, Hugh, the big platform studies are adding new arms pretty much as we speak. So anti-inflammatory, immunomodulatory arms, and most recently, I think, a couple of arms looking at coagulation and the thrombotic consequences. Yes. It would seem reasonable to think about trying to queue up, either do the preliminary studies that would give them the justification to include it, or accept that data is there and maybe put it in the queue, because the case you've described seems pretty compelling to me, at least to evaluate.
Well, I think that's absolutely right, Mike. And obviously, TopMedTalks has got a very diverse and broad audience nationally and internationally. So if there are other groups that would like to do this isn't proprietarial. The science is all out there. If any have appropriate powering and capacity to a trial such as that, I do think it would be an appropriate molecule.
Before you tell me about the other polymorphisms, Hugh, when I try and read about this, and I read about the ACE2 receptor being a part of it and the way the virus gets in, there's another sort of 5-letter thing they talk about as well. They get the impression is a protease that's in play of some form. Does that have a polymorphism too? Is that?
Yes, there will be polymorph variants. No one's really focused on the other elements particularly well. We know the ACE polys. Angiotensin converting enzyme 2, the ACE2 molecule, has very well recognized polymorphisms. And in fact, the interesting thing is that they are associated, some of them, with the development of hypertension, but also with diabetes and coronary risk. So the big question of why is it that we're seeing hypertensive people more prevalently on our units, for instance, it might be, and it would be a good guess, that these are self-selected as being the hypertensives whose origin of that hypertension relates to ACE2 polymorphic variant. So I think, to use the TV thing, there are other polymorphic variants available. Those are the ones I would look at. The other one I think that's well worth pointing out in terms of gene environment, that there are some other things to say. So in a nutshell, as you know, we have around 20,000 genes that make up a human genome, and it's the presence of those that make us all human. But there are a whole bunch of small variations of those genes, and it's the interaction of those little variants with the environment we expose them to that makes us all different from any human who's ever lived before or will ever live in the future. If you want to find out whether a genetic variant is important, you want to take a group of people who are very much the same. So you might take same sex, same age, same race, and you want to expose them to the same thing. And then the differences you see in outcome will be largely, but not entirely, determined by their genetics. The genetic influence will be expanded. And that's essentially what we're seeing here, isn't it? We're seeing populations, and you could choose people by gender or sex or age, exposed to exactly the same stimulus. And a lot of the variation we're seeing will be down to genetic variation. Now, the biggest and most obvious of those genetic variants is sex. We are seeing a huge difference in severity of illness and indeed in outcomes and hitting intensive care between men and women. Men are suffering much worse. Now, part of that, of course, you could say is due to three things. It could be testosterone is bad. And it seems to be bad for quite a lot of things in life, but it could be that testosterone is just a bad thing here.
Doesn't help for running countries, it would seem.
It would seem not, no, or starting fights and so forth. It's a bad hormone for some reason. It could be that. It could be that there's something on the X chromosome that is good. And of course, we've got to remember that the ACE2 molecule is encoded on the X chromosome. So it could be that something good or beneficial, for instance, that's carried on the X chromosome. Or it could be the most obvious thing, which is it's down to estrogen or progesterone, but potentially estrogen. Now, where are the clues? Well, the clues only come from rodent studies from SARS coronavirus from before, but equally there have been 1 or 2 studies appearing now in rodents, where it appears that if you give coronavirus to a boy mouse, it dies. And if you give it to girl mice, they tend not to. But if you then block the estrogen receptors in the girl mice or take the ovaries out, they then die. So it's looking as if very much it's estrogen that is powerfully protective. Now, estrogen is protective against other forms of severe virus, like some flu viruses. And whilst it's a good meme that men are all rather pathetic and wet, and you give the same virus to a man or a woman, the man gets man flu.
The man flu.
Just powers through it. The evidence is actually clear that it may well be true that men are much weaker morally and emotionally, but it's also true they suffer a great deal more. Their pro-inflammatory responses are dramatically higher in response to many viruses, and it looks as if it's because the women are relatively protected by estrogen.
I'm not going to tell my husband that he now has an excuse.
No, don't tell him. But of course, that means that the natural experiment, the Mendelian randomization, as we would say, has been done. Some members of our population be randomized to receive estrogen, as it were, and some, the men in our population, be randomized to not. And if the biology points to estrogen, we now know the effect size, because we can say how much more likely men are to get severe disease than are women. And we know the difference in estrogen levels, which makes the powering of a study very easy. And again, I'm collegiate in this. We cannot have fragmentation in our community and everyone running off doing their pet project. But the obvious study for me would be to give an estrogen patch or estrogen gel to every person who's male that comes into a hospital with acute coronavirus. To have 2 weeks of estrogen supplementation will have no significant long-lasting effects that we're aware of. There may be a little bit of gynecomastia, breast tenderness. That will go away when the estrogen is stopped. The procoagulant effect, if there is one, I think will be minimal. We're certainly not seeing women dropping dead of pulmonary emboli just because they have estrogen. So, and the numbers, if you work the maths out for such a study, are quite small. You get an answer very quickly indeed. And again, I am collegiate. I'm only, as a patient, going to enter into a trial. But again, as an N of 1, were there no trial capacity, I would absolutely have the estrogen on arrival in a hospital where acutely unwell, because it's unlikely to cause harm and there's a good biological plausibility for benefit and outcome. And I could be entirely wrong in this, but I would give it a go if anyone out there wants to.
Hugh, thank you so much for taking time out of your extremely busy schedule. I know that you are all over and doing some very important work there in London. So any time that you could give us was great. So thank you very much for that. Now, I have a couple questions before you go. So we know that there is a huge movement there in the UK. It's across the world and in everyone's own little corner to help out those who are on the front lines. So, nurses, all types of healthcare workers, the housekeepers, all those things. Can you tell me, have you been involved in any of those?
Yeah, so we are trying to raise money for our intensive care community, and that's by no means to belittle the impacts that have been felt by everyone from receptionists and cleaners and administrators and helpers, all of who have been, frankly, heroic. But in terms of our own community, we've got doctors, some of them very junior, nurses and helpers who've taken a frontline role and, as Monty pointed out earlier, had an absolute battering. I can go around as an intensive care consultant and deliver instructions. We've got nurses used to looking after one patient, now trying to manage 6 at the same time in full PPE. Yeah. So we're trying to do a fundraise. Anyone who'd like to donate, I would strongly encourage you through the United Kingdom's Intensive Care Society. We're a very lean outfit. It's a charity. It doesn't get wasted on fripperies. And we're trying to build resilience in our medical and nursing and allied healthcare community in two ways. Firstly, to offer psychological support for those that need it. I've not felt the need for support at the moment, other than talking to friends like Monty if I'm in need of a bit of a chat. But I'm well aware that my juniors aren't telling me if they're feeling vulnerable or distressed. Some of our nursing staff are much more open about that, but many will not be too. We need an anonymised way of being able to share their concerns and being connected to helpers, maybe out with their own patch. The last thing you want to be discussing is your depression, the impact on your sex life or your alcohol consumption with someone who might be a colleague.
Yeah.
So we're trying to set that up at the minute. That costs money. The second thing we're trying to do is to support and reward those staff, because this fight is not a short-term battlefield. It's a long-term war. And we're going to be in this for a long time now, not only fighting the coronavirus itself, but trying to deal with going back to treating the other patients we have as well. So there's a lot of learning to be done. We've got to support the education of our staff. We've got to educate the people who've come in from outside, from anaesthesia, or indeed people who weren't traditional doctors at all, and bring them up to speed and not ask them to pay for it. And in Britain, they do. They pay their subscriptions to the charity and then pay again for seminars. So, cut a long story short, we need about £20 million. That will support the psychological input that's needed going forwards, and will allow the ongoing training and support of our staff across the board, nurses, junior doctors, physiotherapists, pharmacists, etc., without asking to dig deep at a time when they've already done that emotionally. So that's what we're on the case for.
And if people want to find that resource, Hugh, where would they find that?
If they just put in United Kingdom or UK Intensive Care Society, they will readily find a donating page. Okay. And I can promise you the money does not go on supporting a lot of waste. Their office is small. Most of us, like me, work for this charity and are unpaid, as Monty has done before. This isn't something that's generously remunerated or indeed remunerated at all.
Yeah. And we'll put a link on our site for that.
That'd be terrific.
In closing, Hugh, it seems like a long time ago, but people are apparently reading a lot more now. And I believe there's some excellent books available.
Oh, well, this is where I must own up to Monty being my agent, getting 20% of everything.
I was just going to say.
No, he doesn't. Well, if anyone wants to know...
paying you 20% of everything I have?
Well, that would be nice. Yes, I've written a few novels. There are some children's books, which I guess are out there as probably £1 or $1. The Voyage of the Arctic Tern and Cloud Sailors, you'd probably buy them secondhand online. But I had another thriller, a medical thriller coming out, which came out, was last year now, Monty? Was it last summer?
Yeah.
It's just a nasty medical thriller. It's called Control, and you can buy it on Amazon or Kindle or as a paperback or however you like it. So if you want to read a light, non-magnum opus type book that's just vaguely nasty,
that was number one for a while. I can't remember what it was. Number one on the pile in our office or something. Was that?
It was number one. It did make it to number 3 in the Amazon bestseller list. So
that's good.
It didn't quite make it to number 1 there, but it was number 1 in some of the other sort of sub charts, as it were. It's a bit like saying I was, best, big in China. It used to be in the 1980s for bands. So. There you are.
That's great.
In Japan once.
Well, Hugh, I can't tell you how much we really appreciate it, and thank you for this great conversation. And we will definitely be putting a link to all of those on the show notes for sure. So the giving pages, as well as a link to Jeremy's Facebook Live event. It's at 5 p.m. UK time on Saturday. And and so we'll see there.
Whoever gives the first million, I'm sure you'll agree to have them on the show, right?
Absolutely.
Why they gave the first million, so that'd be great.
Absolutely. We'll do a whole series around you if you want. That's great. Hugh, and we'll also go to link your book in there too. So I think we'll get you all covered there. But I think it's been a fascinating conversation. I really appreciate the deep dive into the ACE story. I think that's going to be something that we all want to follow and catch up on. I mean, the opportunities of research through this COVID crisis is crazy. It'll be really interesting to see how it all pans out at the end. So thank you. Thanks again.
My pleasure. Thank you for having me.
TopMedTalk.
All right. And thank you for listening to our series, COVID from the Front Lines. You can definitely find more like this at TopMedTalk.com and by following us on your favorite social media platform. Cheers.
TopMedTalk is proud to thank its sponsors, specifically Edwards Life Sciences, for their generous support through this global crisis.